conditional control flow with the CDM8 teaching architecture. Today we will look into a small example how to program in this machine code for the CDM8 architecture some simple arithmetic expressions combined with conditional control flow, in this case just alternative if then else execution. And the kind of program we want to basically program is just described here, where we have a condition out of three variables u, v and w. We want to test whether v is actually larger than u, and in this case the expression 1 minus w minus v should be stored in the result ans. And if this condition actually results into false, we would alternatively just calculate the expression w plus 3 times u minus v and store this instead into the variable ans in memory back. So far we know we also have to say that a minor extra challenge is here, for example, the multiplication by 3, because our architecture doesn't even have a hardware multiplication, so we have to do this in software. And with any kind of constant we have to basically manually work around how to program that. But first let's look at the whole exercise. I suggest we structure it into different steps, so we can easily see in a modular way of our thinking of how to solve this, to just focus on particular parts, and also if we want to test them, check them also basically separately. So if we look for that, I have already prepared something, like in a cooking show. It's a whole pre-step actually already made. So I suggest that we first, as a first step, not even before we even start to program, just rewrite our exercise into a more, formally way to actually quicker be able to read the exercise, and so when we want to cross-check it, so we can easier and faster do that instead of always looking up the text here. And what I mean by that is also already prepared. Just write the whole exercise into a more kind of programming, high-level programming style way, as a kind of pseudocode, where we just have an if statement. If this condition is true, then basically calculate this expression and assign it to ans, otherwise basically this one. And as you already see, this makes it a bit easier to quickly see what we are supposed to do here. And only then we have to first, of course, get our input variables from the memory. Then it's the core part where we have the if statement, and in these two alternative branches for the then and the else case, we have to calculate as an extra step 4 and 5 basically these two expressions. And only afterwards, separately afterwards, we can basically store the result back, which we just have to make sure that both steps 4 and 5 leave the result in the same register, so that one single store statement afterwards will do it for that. So let's first load our input variables. For this, again, our cooking show has prepared something, and we just take that. There we go. So we have now three variables loaded into register, as nicely commented here. And we focus now on the if statement as the core part. And an if statement, in the simple form, it is an if statement and is with some control condition and an and. And in our case, we also extend it into an else part as well. And whatever the condition will be, symbolically we require to test whether v is larger than u. That is basically our test here. So if you look at our textbook, for example, we will see, under control conditions, we see the different control conditions we actually have. And for example, greater would be one way to say greater than 0 we can use as a test here. And then we just need to put the appropriate comparison before. So we want to compare V first with U. So V is basically register R1 and U is register R0, and this would give us this test. And by this we already have step number 3 finished. That's the important thing, keep this actually separate from the part with the arithmetic expressions, because when we test them we also can basically test this separately, for example to make sure whether the if statement takes the right branch, for example. And I have now moved basically the commands for the step 4 and 5 inside, and what I will also do is here I copy in addition also the description of what we are supposed to calculate also again into our local positions here, because this makes it easier for us to basically locally program our exercise without having to look up and down and maybe make any error by just looking at the wrong line or so. So for example, we have now finished our step 3. The if statement is actually there, so we just focus on the then branch, the true branch, and for this we just have to now program the expression 1 minus w minus v, and we forget about the rest so far. Just let's do this first. 1 minus w, okay, 1 is as a constant, so we have to first get it into a register. R3 is not used, so why not just use it? So R3 now has the value 1, and then we do a subtraction. R3 minus w, which is R2, so which leaves us with R2 is 1 minus w. Then we do another subtraction. We take our current result R2 and subtract from it v. V is already in R1, so we can just write R1 here, and we get R1 is 1 minus w brackets minus v. Congratulations, step 4 finished, mission accomplished for that part. We can directly go forward to step number 5, and here we do a similar thing, just in a slightly different expression, just start the same way. We now have, we can't really just start with w plus, because we have to add to w something that is basically an expression on its own. So we have to basically follow, priority of operators, first brackets, afterwards multiplication, and only afterwards the addition. So we have to first calculate u minus v. So let's do that. Subtraction. What is u? R0. V is R1. So this is R1 is now u minus v. And now we have to multiply this by 3, which is now a question on its own. How do we do that? And for this actually we have now one basic mechanism, which is basically just the shift or add to its own, which is a multiplication by 2. So for example, I could write shift left arithmetic, register R1, and if I do this, this would basically do a multiplication by 2, so we would get 2 times u minus v. Of course you would now say, but we want 3 times and not 2 times. But in this case the 3 times is then basically simple, because we just take the multiplication by 2 and add the original value to it, and it would be then 3 times. We just when we want to start here, we just have a slight problem, because the value u minus v was in R1, but we have now overwritten here R1, so we can't just directly do that. So we have to first add here a move statement where we, for example, copy R1 into another register, let's say again R3, and so R3 is also U minus V. And in this case, we can now write R3, R1, add them together, and now R1 is actually 3 times U minus V. And that's pretty much what we wanted. So the only thing what is left is to add them together with W. So I could, for example, write W is in R2 and the other expression is in R1. So R1 now is W plus 3 times U minus V. And you see here we have already nicely achieved that in both cases our end result of the if branches is in R1. By having done that, we can basically afterwards, just leave as a separate step to store our result from R1 back into the memory at location arns. So we get first the address. We can use actually now any register except from R1, so why not just use R0, and we get the address of the memory location arns. And afterwards we take the address and say which variable we want to put back into memory, and by doing so we would basically say our answer is now, and I just write result because I can't say exactly what expression at this particular point in time it will be, because it will depend on the control flow. It's either that expression here or this expression, so I just say we finally store the result back into ans. That's basically what we do. Let's see whether the whole program compiles. It actually does. It looks good. And one thing is also, quite useful in these program exercises, because they have also for clarification, they give you some examples on what kind of input data will lead to what kind of output, and we basically just take them over. We already have them here copied as well, and we have now two cases for the if statement, one case true, the other one case false, so we at least should have two different test cases to have at least the first guess whether it's correct or not. And we know also the results from the descriptions, so we just have to make care that the input data reflect, for example, one particular line. Here we have first the else case 543. What I can do now is I switch into fast mode and I just compile it, and then I run my whole program, and the result is actually 6. That's exactly what was supposed to be. So what is now actually left would be to also take the other line from this example and test for 3, 4, 5 what the result will be in this case. So don't forget to compile again and also run it, and our result is -8. That's exactly also what's supposed to be here. So in this case we have a simple test. So we have tested for both the true and the false case in the if conditions. That at least gives us certain confidence that actually our whole program is correct. And with this we leave it as a final statement actually, because I did a lot of extra comments here, and also copying the whole expression and also writing here kind of pseudocode. I just really recommend to do this, because writing programs in assembly code under test conditions is very stressful, and a single mistake can be very hard to find. And these kind of commands, they provide you with some anchor, so that you can always then, for example, if there's something wrong, basically go back step by step and actually check where the error comes from. So it's actually also highly advisable to comment your assembly code, so that you have an easier way to trace back, what was supposed to happen, and if something is wrong, where exactly it actually went wrong. And that's pretty much it for today.